Okay, we want to talk a little bit about relabeling basic graphs. Now, yesterday we created the graphs, and today we're going to see why these graphs are so general and so, well, we're not really going to see why they're so applicable. We'll work that through as we go through the rest of the course. But right now, we just want to talk about the idea of relabeling a basic graph. So here's a basic graph of the squaring function. I'm going to start by drawing a y-axis and an x-axis, and I don't draw the y-axis. I didn't draw the y-axis below the x-axis because, of course, the squaring function has a range of values that are all positive. When you square numbers, you always get a positive, so we don't need negative y values. Okay, now the graph is defined from x equals -2 over 2 x equals 2. So I use as much of the x-axis as I can to get that domain, the domain from -2 to 2. Okay? To make a decent graph, I want to scale the graph carefully, so I'm going to subdivide the interval from 0 to -2 as closely as I can in half. And of course, here's going to be -1. And I'll subdivide the interval from 0 to 2 in half, and that's where 1 is going to go. I think I got a little too far that way. Let's see, we got that, and we got that. Yeah, you know, I'm not very good at this, mainly because I'm not right in front of the graph because I don't want to block the camera. But there we have it. And of course, not having these in exactly the right point tends to distort the graph a little bit, and we don't quite get the right shape. So we want to do this as accurately as possible. Okay, well then I subdivide this interval in half. So here's -1/2. And here's 1/2. Another problem I have, of course, I never quite know where the point of the chalk is going to go, so it can go to one side or the other. Okay, then I can go ahead and put a point here and a point here, and we know that that's 3/2. Of course, we can think in terms of decimal equivalents, but I like to use the fractions because we want to get away from the idea that a calculator is what does arithmetic. Our brains are what do arithmetic, and sometimes we use the calculator not as a crutch because our brains can't do it, but for speed when we know what we're doing. Okay, well, anyhow, talk more about that later. Okay, so up here, we're going to need 4. Now, you've probably been taught to make graphs where you have equal scales on the x and the y, so that would mean 4 would have to be up this much higher and have to be way up here. That's not necessary in this course, but it's a good idea when you're first looking at the graphs to get the relative shapes. We're going to take a deeper look at the relative shapes of these graphs and how they stretch and shift and all that sort of thing. Okay, well, we subdivide this interval from 0 to 4 in half, and the chalk went too high there, but we're going to live with it. Okay, so here's 2, and I subdivide the interval from here to here in half, and that gives me, of course, where 3 is, and here is 1, and then here's going to be 1/2, and here's going to be 1/4. 1/2 is half of 1, 1/4 is half of 1/2. Okay, now we can plot our points. We know that -2, 4 is on the graph, so if I can do this with some kind of accuracy, here's a point. -1, 1 is on the graph. Here's a point. -1/2, 1/4 is on the graph. So that point's about right. And then 0, 0 is on the graph. 1/2, 1/4, 1, 1, 2, 4. And right here is a graph of the basic function, because the basic function is confined to the domain consisting of the points, consisting of x values, -2, -1, -1/2, 0, 1/2, 1, 2. 7 points. It's a 7-point graph. And every one of these points has coordinates that we can completely understand. Okay, so there we have it. Hopefully, let's see, symmetry's almost okay. Not too bad. Could be improved. Okay, so here we have the graph of the basic function. Its domain is a set of points, -2, -1, -1/2, 0, 1/2, 1, 2. Its range is the set 0, 1/4, 1, 4. Those are the y values. That's it. Now we can do the extended function. That's the wrong color to use. Okay, let me use this one. Okay, the extended function is represented with some accuracy depending on how well you've drawn the graph by the curve from here to here. Okay, so the extended basic function has domain, the closed interval from -2 to 2. And I assume that everybody's seen the notation for closed interval, but the brackets indicate that we include the point -2 and the point 2 and all the points in between. So right there is the domain of this function. The range, well, the range is all the y values. Well, every y value from 0 up through 4, including 4, is in the range. So the range is the interval, closed interval, 0, 4. Okay, well, those are the functions. Now, we're really talking about relabeling, so let's do an example of relabeling. Okay, I'm going to use a different color to relabel the axes. And I want to relabel so that the domain becomes -8, 8. For the extended function, we want the domain to be -8, 8. And we want the range to be, let's say 0, 100. Okay? Well, that's easy to do. We just put another set of labels down here. This point now becomes -8. This point becomes 8. And 0 stays 0, but 4 becomes 100. And then the other points are relabeled accordingly. Now we created the graph by subdividing intervals from 0 to 2. We subdivide it in half, so that if we subdivide the interval from now 0 to 8 in half, we're going to get 4 where we previously had 1. Now, of course, you can do this by ratio and proportion. You can do it by arithmetic. 1 is half of 2, so this had better be half of this, right? But looking at it more geometrically, I subdivide the interval from 0 to 4 in half, and I get 2, and that's got to correspond to 1/2. And over here, you see I'm going to have -4 and -2. And of course, 0 is still going to be here. Now, for the 100, it's a little harder to subdivide. I mean, it starts out okay. We subdivide the interval from 0 to 100 in half, and we get 50. And we subdivide that in half, and we get 25. Now, if we subdivide that in half, we're going to get 12.5, and that's not a very convenient number to put in the graph, so maybe we do something a little different here. But at least I have this much of a scale. Now I could proceed then to, let's say, divide each of these intervals into 5 parts. Divide like this, and this, and this, and this, and I'd get 55, 60, 65, 70. Okay. Well, I'm not going to try to do that because there isn't room on the graph, but that could be done if you had a bigger graph, whatever. Okay. Anyhow, now we have the relabeled graph, and I'm going to draw. I don't want to draw this right on top of the other graph, but you get the idea. That the curve now represents 2 different graphs. It represents the extended basic function and the relabeled extended basic function with the new domain and range. Okay, well that's what we mean by relabeling. Now there are other things that can happen with relabeling. If I wanted to have the domain go from 0 to 32, then 0 would be over here, and that would actually move my y-axis, wouldn't it? Because y-axis has to be where x equals 0. And I might have a domain from -20 to 40, for a range of -20 to 40, so that the coordinate of this point would be -20, the coordinate of this point would be 40, and that would move the x-axis up to about here. Well, think about that a little bit, because that's important. But for right now, we'll stick with this idea.